Hi, my name is Farish, Hashim, and today I want to discuss and sketch a graph of the following function. The following function are fx equal to x power of 5 minus 16x power of 3. So the first thing that the question asks is x-intercepts. So if we want to find the x-intercept, we do the fx, which is the function, equal to 0. So here the function is x power of 5 minus 16x power of 3 equal to 0. So we factorize it. X power of 3, x power of 2 minus 16 equal to 0. So here we got x power of 3 equal to 0, and x values will be 0. For this one, we factorize and we get x minus 4, x plus 4. So the x values will be x equal to 4 and x equal to negative 4. So we get 3 values of x here. And for the y-intercepts, we need to let x equal to 0. So here, f0, and we just plug it into the equation. 0 power of 5 minus 16, 0 power of 3. So we got 0. And so the x and y intercept will be 0, 0, 4, 0, and negative 4, 0. And the next one, the question asks us to do the open interval where the function is decreasing or increasing. Interval where the function increasing or decreasing. So if we want to find the interval, we need to do the first derivative and equal it with 0. fx x power of 5 minus 16x power of 3. So if we do the first derivative, we get 5x power of 4 minus 48x power of 2 and equal it with 0. So we need to factorize here. 5x power of 2 minus 48 equal to 0. So the x values will be x power of 0, x equal to 3.0984, x equal to negative 3.0984. So we do the straight line here to do the interval. We plug in the values that we get earlier. 0, 3.0984, and 3.0984. So we put any values that the range between the x values. So here I just choose negative 4 and negative 1, 1 and 4. So to determine whether the function is increasing or decreasing, we just plug in the value that we put earlier into this equation, into the derivative equation. So here f set negative 4, we get 512, which is positive. Here we plug in f negative 1, we got negative 43, negative values. f1 negative 43, negative value also. f4 we got 512, positive values. So here we have 4 intervals, 2, 3 and 4. So the first one is positive, so it will be like this, increasing. And the second one is negative, we do going down. And the third one also negative, going down. And the fourth one, we got positive, so increasing. So from this equation, from this line, we can conclude which one is positive and which one is negative. So f is increasing on, so here increasing from here, negative infinity to negative 3.0984. So negative infinity to negative 3.0984. And one more thing, from here to here, 3.0984 to positive infinity, 3.0984 to positive infinity. And f is decreasing on here between this negative 3.0984 to 0 and 0 to 3.0984. So the next question, the question asks us to find the x coordinate of the inflection point. X coordinate of the inflection point. So we need to do the second derivative to find the x coordinate. And 5x power 4 minus 48x squared. So if we do the second derivative, we get 20x power of 3 minus 196x. So we need to do the second derivative equal to 0, f x equal to 0. So here 20x power of 3 minus 96x equal to 0. So if we factorize, we get for x 5x power of 2 minus 24 equal to 0. So x equal to 0, x equal to 2.1909, x equal to negative 2.1909. So to make it easier for us to do in the graph, we find the y values also. So we plug in these three values on the first equation, which is fx equal to x power of 5 minus 16x power of 3. So if we plug in f2, we get 117783. If we plug in these values, we get negative 117783. And also if we plug in f0, you know that we got 0. So the coordinate will be 2.1909 117783, negative 2.1909, negative 117783, and also 0, 0 in the graph. So the next one, the question asks us to do the open interval where the function is concave up and concave down. So we just do the same way like we do the inflection point. We do the second derivative and equal it with 0. So 20x squared minus 96x equal to 0. We also get x equal to 0, x equal to 2.1909, x equal to 2.1909, I'm sorry, 0 negative. So we do again a line and put the values here. So in between we put here negative 1, 1, 4, 4. So we plug in again the values here plug in into the second derivative. We get which is concave down. If negative, will be concave down. Concave up. Negative again. Concave down. We get concave up. So we know from here the concave up will be negative 1. So from here to here, negative 2, 1909 to 0, and one more thing, 2.1909 to positive infinity. Concave down here, this way. Negative infinity to negative 2.1909, and concave down here 0.0 to 2.1909. And the last one, the question asks us to find the local minima and local maxima. Local minima and local maxima. So if you want to find the local minima and local maxima, we can find from the first line that we do. If the line was like this, surely will be local max. And if like this, local minimum. So like local maxima is minima 3.0984. Local maxima is negative 3.0984. So if you want to find the y values, we just plug in this equation, the first one, and we will get 10.365. If we plug in again here, we also get 190.365. Okay, the last one, we will do the graph sketching. So I just roughly do the line of the graph. So the first thing we must do is we plot the local maximum, the local minimum, and the inflection point. So the local maximum that we get earlier is negative 3.0984 and 190.365. So the local maximum here will be in this area, and for the local minima will be in this area, around here, and this also will be around here, and also here inflection point. So the graph start from here, which is the graph will start from here, the x and y intercept, going down to the local max, go to the inflection point, local min, and again here. So it's just a rough sketch. So here local max, inflection point, local min, and here will be x y intercept that we got here, x y intercepts. So it's just rough on how the graph will be. Thank you.